what we're going to be talking about here is going to be series. And the reason we're talking about series is because there's a lot of applications in calculus that allow us to understand things about series, about adding up sequences. So a series is a sum of a sequence of this form. And we're going to start using the sigma notation. Just using the sigma notation might be the trickiest thing we're going to do, at least for a little while, regarding series. And so a series is just the sum of the first n numbers in a sequence. So it's just adding them up. In your previous courses, you have probably talked about ways that you can add up a geometric sequence or an arithmetic sequence of numbers. There's formulas for those things. Usually, those work great for a finite sequence of numbers, adding up a finite set of numbers. But what we're going to be looking at is what's called an infinite series. So it has essentially the same definition, except there's infinitely many terms. So we don't just go to n terms or some finite number of terms, but there's going to be infinitely many of them. We're going to write them in this way. We're going to write them two different ways, using the sigma notation, and then also using using this notation. And this term right here, this is called the general term. This general term here can be used just like the sigma notation to figure out what any particular term is going to be. So we're going to be figuring out either how to add up these series, and what we're really interested in is the infinite series. And you might start seeing a tie right now to those improper integrals. Those improper integrals are going to play a big part in this. So we're either going to try to add them up, or at least just try to figure out if they could be added up. We're going to try to figure out if they converge or diverge. And a lot of times when they converge, we're still not going to know what they add up to, but we do know it's going to be a finite sum, which is kind of a weird thing to think about. But we're not always going to be able to find the sum, even if we know that it exists. So one other thing that we're going to need to know is something called partial sums. These partial sums are important in defining what it means for a series to converge. So a partial sum is just the sum of the first n numbers in the sequence. So if you add up the first n numbers, this looks a lot like, especially like right here, this looks a lot like that first formula I gave you for a series. These partial sums, if the series converges, which means that all of these numbers, all these infinitely many numbers are going to add up to some finite number. So if it converges, then these partial sums are going to get closer and closer to that number, that limit, as n gets really big. And so one of the things we're going to talk about is we're going to see some sums, some series where the sum is going to be finite, but it still diverges. And we'll look at why when we get to an example like that. So this is the definition of the convergence of a series. A series converges if the limit as n approaches infinity of those partial sums. This s sub n here is a partial sum. So if the limit of the partial sums exists, and remember the partial sum is equal to this right here, the sum from k to n of the first n terms in the sequence. So if that limit of the partial sums exists, then it converges. If that limit does not exist, then it diverges. And it could not exist for different reasons. It could not exist because it's infinite. It could not exist because it oscillates, which there's a classic example, a fairly simple example of a series that oscillates, or the partial sums oscillate, and so it does not converge, it diverges. This is a theorem that can be really useful to prove that a series diverges. And it seems kind of contrary to say, okay, well, I'm going to use this theorem to say that it diverges because it doesn't say anything about diverging. But if you remember from your geometry class when you're talking about logic, you guys remember what the contrapositive is? What this theorem says is if an infinite series converges, then the limit of the terms in the infinite series. So each individual term in the sequence, those are going to get really close to 0. So if this thing converges, that means that we're adding up numbers. We're adding up infinitely many numbers. And if we're going to add up infinitely many numbers, they have to get really close to 0. If they're not getting really close to 0, then we're going to get an infinitely large sum. So then what our contrapositive is going to tell us is if the terms don't go to 0, if the terms aren't getting really, really, really small, then this is not going to be true. Then the hypothesis part isn't going to be true. And so the infinite series will diverge. So it says that if the series converges, the terms have to get really small in the end. But it doesn't say that if the terms get really small, then it's going to converge. So you have to be careful with the logic there. The most useful part of this is going to be that we could say if the terms don't get really small, then the series is going to diverge. Because if we add up numbers, even if they get really close to 1, if we add 1 a bunch of times, if we add 1 enough times, infinitely many times, we're going to get an infinite sum. So the terms have to get really close to 0 in order to get that finite sum. Does that make sense?